Assalamualaikum and hi everyone. Today I will explain what chemical bonding is and how it's happened during baking with common ingredient. Firstly, chemical bonding is the connection between atom to form molecule or new substance. In baking, these bonds are constantly broken and reformed when we mix, knead and bake the dough. There are three main types of bonding. First one is ionic bond. For example, sodium chloride, which is salt in the dough. Next is covalent bonding. We can find it in sugar, honey, flour and fats like butter. Last one is hydrogen bonding. This is between water molecule, flour, proteins and sugar. Why bonding is important in baking? First one, it determines the texture of the bread. Next, it affects flavor and aroma. Lastly, it helps with dough structure formation. For example, dough become chewy because of gluten bond. Bread rise due to carbon dioxide gas from yeast. And last, brown color from due to heat reaction. So, baking is not just a cooking, it's an active chemical process. Next, I will hand over to the second presenter to explain the role of yeast and fermentation.
Hi everyone, I'll be taking over to talk about instant yeast, which you can see here in the image. First of all, most people think of a yeast is just as the powder, but it's actually a living organism from the fungi family. In its instant form, it's dormant, but the moment we add warm water and sugar, it wakes up. This starts a biological process known as fermentation. Think of yeast as the engine of your dough. It's alive and it's hungry. So, what exactly happened during the fermentation? When yeast consumes sugar, a fascinating chemical reaction occurs. We can represent it with this simple equation. Sugar to carbon dioxide, CO2 plus alcohol plus energy. As the yeast breaks down the sugar, it releases carbon dioxide gas. Now, here is the magic. That gas gets trapped inside the elastic walls of the gluten network. As more gas is produced, those walls stretch, causing your dough to expand, rise, and becoming incredibly light. During this process, several things are happening at a molecular level. First, the complex chemical bonds in the sugar are being broken apart. Second, entirely new molecules are being formed, which creates those tiny air pockets we see in bread. This is how we get that amazing transformation, turning a dense, heavy ball of dough into a soft, fluffy, and airy lump. Without yeast, your bread simply wouldn't be bread. It would be flat. The texture would be hard and rock-like, and most importantly, you would miss out on that wonderful earthy aroma that only fermentation can provide. Yeast is our biological leavening agent. It's what gives bread its life and soul. So, now that we know how yeast powers the rise, what fuels the yeast? To answer that, I will pass it over to our third presenter who will explain the vital roles of sugar and honey. Thank you.
Before I start my part, first of all, I want to introduce myself. So, my name is Nur Fatah binti Shamsus. You can just call me Kia. Okay, so today I would like to explain the role of sugar and honey in baking from a chemical point of view. For the third step, sugar and honey are not only used to make food taste sweet. They are made of tiny particles called molecules, and these molecules are joined together by covalent bonds. When sugar and honey are heated in the oven, the heat causes these bonds to break and change. This process is called caramelization. So, caramelization is very important in baking. Because what? Because it makes the dough change color from pale to golden brown. It also produces a nice sweet and toasty smell that makes baked food more attractive. So because of this process, the taste of the bread will become richer and more delicious. Besides that, sugar and honey also have other important roles. They act as food for yeast. When yeast eats sugar, it produces gas that helps the dough rise and become fluffy. So sugar and honey also help to keep moisture in bread. It means the bread does not become dry easily. They also help to make the bread soft and tender when we eat it. So in conclusion, sugar and honey are not just for sweetness, but they are chemically active ingredients that play an important role in baking. So that's all from me.
Hi everyone, now I will explain about high protein wheat flour and the formation of gluten. As you know, the most important things that you need in the baking is flour to make your food to make a dessert that you are baking to become a solid structure. Like when you make a bread, you need the flour to make it solid. So in this process or in this baking, I will explain to you a little bit about the flour, what inside it and what it will become. Okay. In flour, there are two main proteins, which is glutenin and gliadin. Okay, when flour is mixed with water, the water molecules will form a hydrogen bond with this protein that consists in the flour. When the dough is kneaded, which is when it became a solid structure, these proteins combine and form glutinate group. The bonds that are involved in this process is hydrogen bonds and disulfide bonds, which is between the proteins. And the function of the gluten that is make the dough elastic and chewy, which is when you mix the flour with water and egg and the other stuff, the flour will not become a solid structure. But the solid structure is not as solid as rock, but if you touch it, it's a little bit stretchy, which is you can stretch it to a long figure or to a small figure, and you also can cut it into a small pieces, which is make it elastic. And if you chew the flour, you can taste the texture that it's not too solid and it's not too soft, which is it's chewy. That's what makes you can knead the dough into a different shape. Okay. The function, other than that, it retains CO2 gas from the yeast and give a structure to the bread. As I said, it will make the dough solid, which is it can hold the structure of the dough, so that if you make the dough shape circle or heart or square or anything you like, it will hold the shape until it will bake, which is until it became a bread. So if your dough in the shape of circle, so your bread will be a circle. If the gluten is too little, your bread will be too soft, and if the gluten is too much, your bread will be hard. So this is why it's important for you to follow the menu or follow the instruction to how to make the bread, which is If they say you have to put 500 grams of gluten, then you have to put 500 grams. You cannot put 550 grams or 450 grams. So you have to follow like legitly like how the instruction says. Therefore, the control of the chemical bonds is very important. Next, the last presenter will explain the role of heat, butter and Maillard reaction. Thank you.
Assalamualaikum and hello everyone. Today I will explain the final and very important chemical reaction in baking, which is known as the Maillard reaction. The Maillard reaction happens when baked food is exposed to high heat, usually between The Maillard reaction happens when baked food is exposed to high heat, usually between 140 to 165 degrees Celsius. At this temperature, the surface of the bread becomes hot and dry. This reaction mainly happens on the outside surface, not inside the bread. That is why the crust turns brown, while the inside stays soft. For example, when the bread is baked on the oven, the top becomes golden brown, but the middle remains white and fluffy. This shows that the Maillard reaction happens when the heat is strongest. Now let's talk about what happened during the process. During the Maillard reaction, proteins from flour and milk react with sugars. First, the proteins break down into smaller parts called amino acids. Then, these amino acids react with sugars. At the same time, all covalent bonds break and new bonds are formed. These reactions create new chemical compounds. These compounds are responsible for the brown color, pleasant smell, and rich taste of baked food. Even though the process is complex, we can easily notice the result through our sense. What we can see, what we can smell, and what we can taste. Besides, we're gonna talk about the role of butter and milk. Butter and milk play a very important role in the Maillard reaction. Butter contains fat and milk solids, while milk contains proteins and lactose, which is milk sugar. Fat helps to transfer heat evenly, making the browning process better. Milk sugar and proteins also help the Maillard reaction happens more effectively. Because of butter and milk, the bread browns faster, the flavor becomes richer, and the aroma becomes more appetizing. This is why baked food with butter usually tastes better and smell nicer. Last but not least, we're going to discuss what the Maillard reaction produces. As a result of a Maillard reaction, we get a crispy and golden brown crust, a delicious baking aroma, and a deeper and richer flavor. Without the Maillard reaction, baked food will look pale, smell plain, and taste bland. In conclusion, the Maillard reaction is very important in baking because it improves the appearance, smell, and taste of baked food. That's all from me. Thank you for listening.